In this video, I'm going to go over reference angles. Reference angles are really useful when we're trying to recall values from the unit circle. And so let's talk about what a reference angle is and then how we can use that in conjunction with the unit circle. So the definition we have here is the reference angle is the acute angle formed by the terminal side of the angle and the horizontal axis. A reference angle is always between 0 and 90 degrees or 0 and pi over 2. So by terminal side of an angle, we always mean kind of the ending side of this angle. And remember, the horizontal x is the initial side. So in each of these images here, the reference angle is always the angle that is made with the x-axis. So this angle, which color should I use? How about green? So this right here is the reference angle. Here is the reference angle, and here is the reference angle. So what I like to say is that, and then I guess in the first image, the reference angle is that. So what I like to say is that the reference angle is the angle that gets us back to the x-axis as quick as possible. So, and it's always between 0 and 90 degrees. So our reference angle is always an acute angle. Okay, so let's do this example and then we'll talk about how this works in conjunction with the unit circle. So I'm going to draw each of these angles. So the reference angle for 240 degrees, well, 240 is a little more than 180 and less than 270. So there's an angle of 240 degrees. The reference angle is the angle that is an acute angle that gets us back to the x-axis. So that angle right there that I drew in red is the reference angle. And that angle is, well, halfway around the circle is 180 degrees. And this entire angle that I drew is 240. So that reference angle here is 60 degrees. The second one, 2 pi over 3. 2 pi over 3 is an angle on the unit circle. And that is, it's less than pi. So it's somewhere, actually, it looks a little bit more like this. There's 2 pi over 3. If you want to convert that into degrees, that's the same thing as 120 degrees. Okay, so oftentimes, if we're graphing, it makes things a little easier if we write this in degrees. But this angle, 2 pi over 3, is in quadrant number 2. Our reference angle is going to be this angle here. It's the angle, again, that gets us back to the x-axis. So halfway around the circle, once again, is 180 degrees, or pi. Since our initial angle, 2 pi over 3, is in radians, we want to give the reference angle in radians. So if you're not sure how to do this, well, we know that halfway around the circle is pi. So I'm going to subtract 2 pi over 3, get a common denominator. I'm left with pi over 3 as the reference angle. So this angle in here is pi over 3. The next one, 330 degrees. 330 is almost all the way around the circle. So there's 330 degrees. What's left over to get us back to the x-axis is this angle right here. 360 minus 330 gives us 30 degrees as our reference angle. And again, because this angle initially was given in degrees, we want our reference angle to be in degrees. All right, and then lastly, negative 13 pi over 6. That was a bad arrow that I drew there. Negative 13 pi over 6. Well, negative 13 pi over 6, that is bigger than negative 2 pi. And remember, 2 pi or negative 2 pi is one time around the circle. So since this is given, since we have a negative value here, I'm going to be going clockwise around the circle. So negative 13 pi over 6, I'm going to just do a little manipulation. Negative 12 pi over 6 minus pi over 6. That would give us negative 13 pi over 6. And the reason I broke that up is because this angle right here is negative 2 pi. So that's one time around the circle. and that is going to be clockwise. So negative 2 pi gets us to here, and then I have a little bit more to give us negative pi over 6 section. So that's negative 13 pi over 6. So the reference angle is just this sliver in here, and that angle is pi over 6. So one thing to notice is that we always want our reference angle to be positive. I don't know if that's in the definition, but you might want to make a note of that. Always positive. Reference angles are always positive. And then one thing to also note is that for the radian reference angles, notice that the denominator for 2 pi over 3 is 3. And for our reference angle, it's also 3. And then we have 6 and 6. So the reference angles, if we're dealing with angles in radians, the reference angles always have the same denominator. Now, the reason that this is useful is if we're dealing with an angle on the unit circle, and let's just talk about 2 pi over 3 because that's an angle on the unit circle. Let me do some erasing here. I'm just kind of cleaning this up, and I'll just redraw this angle. All right, so 2 pi over 3 is up here, 2 pi over 3. And that corresponds, or that reference angle was pi over 3. And pi over 3 is a value on the unit circle. So the coordinates for pi over 3 are 1/2 for x, root 3 over 2. Now 2 pi over 3 has the same reference angle as, or the reference angle is pi over 3. So the coordinates for 2 pi over 3 are the same as what's in the first quadrant. The only difference is that the signs might change depending on what coordinate I'm in. So because I'm in, or what quadrant I'm in. Because I'm in quadrant 2, the x coordinate is negative and the y coordinate is positive. So in that first quadrant, and I guess my pen just died here. So in the second quadrant, my x coordinate is negative, my y coordinate is positive. So the x coordinate is going to be negative 1/2, and the y coordinate is going to be root 3 over 2. So same coordinates, but just the signs are different. Now if I go around the unit circle, there are 2 additional angles that have the same reference angle, that are a reference angle of pi over 3. So I could draw those angles. It's going to be down here and down here. And, I could just draw that circle. Imagine that that's a circle. So those angles, the angle in quadrant 3 is 4 pi over 3 and then 5 pi over 3. And notice that those have the same, those are all a denominator of 3. So those have the same reference angle as 2 pi over 3. So that tells us that the coordinates are all the same. They're all 1/2 comma root 3 over 2. And the only thing I need to be aware of is what the signs are. In quadrant 3, the signs are both negative. In quadrant 4, the x coordinate is positive, the y coordinate is negative. And so this is how we can use reference angles. If we know what the reference angle is, we can use the coordinates from the first quadrant to find the coordinates of these other kind of corresponding angles. All right, and then let's do a couple examples here. This first example, says, for each of the following angles, find the reference angle, the quadrant of the terminal side of the angle, and then the sine and cosine of each angle. If the angle is not one of the angles on the unit circle, use a calculator. All right, both of these angles are on the unit circle, so we can do this using the unit circle. Let's look at 135 degrees. That's in quadrant 2. So when we talk about the terminal side, this side is the terminal side. It's the side where the angle terminates or ends. So this angle here is, we can label it up here, 135 degrees. It's basically just saying that this angle here is 135 degrees. And we can see that that's in quadrant 2. The reference angle is this angle here. What angle gets us back to the x axis? So if we know that this is 180 degrees, 180 minus 135 is 45 degrees. So that's the reference angle. I can put RA here. And then I want sine of 135 degrees and cosine of 135 degrees. Now, using the fact that the reference angle is 45, 45 is here, and the coordinates for 45 degree, for an angle of 45 degrees, the coordinates from the unit circle are root 2 over 2 and root 2 over 2. I'm going to use those same coordinates to evaluate sine of 135 and cosine of 135. Just note that in quadrant 2, the x-coordinate is negative and the y-coordinate is positive. So for sine of 135 degrees, I'm just going to use the y-coordinate, which is positive root 2 over 2. And then the x-coordinate will also be root 2 over 2, but it's going to be negative because we're in quadrant 2. All right, the second one, 5 pi over 3. I'm going to do this in much the same way. The difference here is that we're in radians, and 5 pi over 3 is down here. The reference angle for 5, and so let's just say that that's quadrant 4 to answer that first part. The reference angle is this, and that's pi over 3. And so pi over 3 is here in quadrant 1, and the coordinates for pi over 3 are 1/2 comma root 3 over 2. So those are our x and y's. So we found the reference angle, and then we just need to find sine of 5 pi over 3 and cosine of 5 pi over 3. Now we're going to use those same coordinates that we had for our reference angle. When we are in quadrant 4, the first coordinate is positive, the second, or the y-coordinate, is negative. So sine of 5 pi over 3, that's going to be the same y-coordinate as our reference angle, but it's going to be negative. So negative root 3 over 2, and then cosine will be 1/2. All right, and then moving down to this second one, or I'm sorry, these other set of examples, it says, use reference angles to find the exact value of each expression. So sine of 300 degrees is down here. And this one is much the same as this. 300 degrees is the same as 5 pi over 3. So here the reference angle is 60 degrees. That's 60 here. And the coordinates there, we already found those in the previous example. And because this is in quadrant 4, the y-coordinate is negative. Sine corresponds to the y-coordinate, so this is negative root 3 over 2. Cosine of 4 pi over 3. 4 pi over 3 is in quadrant 3. In quadrant 3, both coordinates are negative. The reference angle for 4 pi over 3 is pi over 3. So I can think about that up here. And again, same coordinates as what we saw on the last two examples. This is 1/2 root 3 over 2. Cosine is the x-coordinate, and because we're in quadrant 3, it's negative, so this is negative 1/2. So those two are pretty straightforward. These next two are a little bit different because the angles that were given here are more than one rotation around the unit circle. So I need to do a little bit of arithmetic to find a coterminal angle for 43 pi over 6. Now remember, one time around the unit circle is 2 pi. 2 pi with the same denominator as the 6 is 12 pi over 6. So 12 pi over 6 is one time around the unit circle. And I want to keep going until I get as close to 43 as I can without going over. 12 pi over 6, if I have 3 of those, that's 36 pi over 6. And then I have 7 pi over 6 left over. So if I was to draw this, I'm going around the circle 3 times. 1, 2, 3. So that gets me 36 pi over 6. And then I need to go 7 pi over 6 farther. So right here. So there's 43 pi over 6. So the reference angle here is this guy right here, pi over 6. So if I think about that in the first quadrant, pi over 6, the coordinates there are root 3 over 2 and 1/2. So 43 pi over 6 is in quadrant 3. Both coordinates are negative in that quadrant. So I want cosine of that angle. So I'm going to use root 3 over 2, but it will be negative because I'm in quadrant 3. So this answer is negative root 3 over 2. Okay, and then we'll do this last one in a similar way. Sine of 1470. So I take that angle, 1470. Now that we're in degrees, each time around the circle is 360. So I need to see how many 360s fit into 1470. And 4 of them added together is 1440. So I just left over, I have plus 30 degrees. Okay, so if I was to draw that angle, 1440, now I'm going to go around the circle 4 times. 1, 2, 3, 4. That gets me 1440, and then I go a little bit farther to get the extra 30 degrees. So this angle is 1470. The reference angle here is 30 degrees. Okay, so for 30 degrees, those coordinates are, root 3 over 2 and 1/2. Now, when the reference angle is in the first, when my angle that I'm concerned about, here it's 1470, is in the first quadrant, the coordinates are just the same as what's on the reference angle. So I don't have to do anything with pluses or minuses. Everything's going to be positive. So sine of 1470, that's just the y coordinate at that angle. So this is 1/2.